Hello friends, welcome to Learner's Planet. Friends, this is our second session for Trigonometry Advance level problems. In the previous session we discussed some basics and some problems. In this session we'll be taking more problems, and I would suggest you to go for the previous sessions or the basic sessions of trigonometry before you come for this session. Okay, so let's begin the session, and whatever you find new in the session, just note it down, and before you come for the next session, do revise that also. Okay, so let's begin. Now we have this question, and before I solve this question, I would like to discuss some more concepts over here. See, I have already discussed the formula of sine a plus b, a plus minus b, and cos of a plus minus b, right? Just do not use the distributive property over here. Good number of students make this mistake. Sine a plus minus b, that is sine a plus b, or sine a minus b, that is sine a cos b plus minus cos a sin b. Similarly, cos a plus minus b is cos a cos b minus plus sin a sin b. Though we have already discussed this formula in basic sessions, still we just go for a quick recap. Sin a plus b is sin a cos b plus cos a sin b, and sin a minus b is equal to sin a cos b minus cos a sin b, right? Cos a plus b is cos a cos b minus sin a sin b, and cos a minus b is cos a cos b plus sin a sin b, right? Now I'll explain you the concept how to find out the maximum value of this, right? But every time you don't have to apply the formula or apply the concept. Once you are clear with the concept, then you can do it directly also. Now suppose I have a expression maybe a sin x plus b cos x, right? So what I do, suppose this is there. Okay, now what I do, I divide this entire expression by root of a square plus b square. And if I'm dividing it, I just have to multiply with this also. Now why I am doing this, just listen to me carefully. I have a right angle triangle. Suppose this angle is maybe theta. Okay, now this is a, this is b, then this will be definitely root of a square plus b square. Okay, now what? See, I have a upon root of a square plus b square, that is a upon root of a square plus b square, that is nothing but sine theta, right? Perpendicular by hypotenuse, that is sine theta. So a upon root of a square plus b square can be written as sine theta. So it is sine theta sin x plus b can be written as b upon root of a square plus b square can be written as cos theta. Okay, so this is cos theta cos x, and if you write a over here, b over here, then also that that really doesn't matter. If I take a this and b this, then a upon root of a square plus b square, if I take this, a upon root of a square plus b square will be cos theta. So that can be written as cos theta sin x plus sin theta cos x. So you can go anyway, right? So since in this case I'm choosing a and b over here, so this is the right formula for this. Okay, now cos a sin b plus sin a cos b, or sin a cos b plus cos a sin b is the expansion of sin of a plus b, right? So here a and b are theta and x, so I can write sin theta plus x. Okay, this expression, and this is multiplied by root of a square plus b square, or I can say this is equal to p upon root of a square plus b square is equal to sine theta plus x, right? Now see, sine theta plus x, it is I have already told you the maximum value of sine function is 1 and minimum it is minus 1, right? So sine theta plus x is less than equal to 1 and greater than equal to minus 1, right? So here sin theta plus x is p upon root of a square plus b square. So that is less than equal to 1, greater than equal to minus 1. That means p is greater than equal to minus of root of a square plus b square and less than equal to root of a square plus b square. Now what was p? That is a sin x plus b cos x. Initially we assumed a sin x plus b cos x as p, and p lies between minus of root of a square plus b square and a square plus b square, root of a square plus b square, right? So the maximum value is this and the minimum value is this, right? Now the same funda we will be using over here to find out this maximum value of this expression. Over here a and b are nothing but 1, right? So here instead of a and b you just put 1. So a and b 1. So p is greater than equal to minus root 2 and less than equal to root 2, right? So the maximum value of p is nothing but root 2. Okay, and if you are asked the minimum value, then that will be minus root 2. So this is the concept behind this. If you finally learn this result, if you know this result, then you can answer it without even paperwork. Okay, but you should be conceptually clear why it is happening. That's why I explained you everything. Okay, now other thing is, suppose p is equal to sin x plus cos x. Here coefficients are 1 1. So I take a triangle with sides 1 and 1. Then if this is 1, this is 1, this is definitely root 2. Okay, so now what I'll do, I multiply this expression and divide this expression by root 2. Okay, so here 1 upon root 2 sin x plus 1 upon root 2 cos x. Now 1 upon root 2 is nothing but sin 45, or I can say cos 45. So whatever you wish, you can write cos 45 sin x plus 1 by root 2. I'll write sin 45 over here cos x. So I get this expression as sin of a plus b, right? Cos 45 sin x plus sin 45 cos x. That is nothing but sin 45 plus x, right? Now once again sin theta, and this is actually in p by root 2. Okay, p was sin x plus cos x. This is actually p. Okay, so sin 45 plus x, the values will be between minus 1 to 1. So p by root 2 will be greater than equal to minus 1 and less than equal to 1. So p is greater than equal to minus root 2 and less than equal to root 2. So the concept I discussed earlier, assuming over a and b over here, the same concept I have used. Okay, and if you know the formula, you can directly put it, right? See here a and b as 1, so root of a square plus b square will be root 2. So the value of this expression will lie between minus root 2 to root 2. Okay, so I hope you are clear with this concept, and you must be knowing these formula because they are really important. Now the largest value of sin theta cos theta, the same concept we will be using, but in this case you must be knowing the formula for sin 2 theta. Sin 2 theta is equal to 2 sin theta cos theta. See, if you put a and b both as theta, then sin theta plus theta, that is sin 2 theta, is equal to sin theta cos theta plus cos theta sin theta, that is 2 sin theta cos theta. Okay, so sin 2 theta is equal to 2 sin theta cos theta. Now why we are doing this? You must be knowing this, why we are doing this. See here, the value of sin theta lies between minus 1 to 1 and value of cos theta lies between minus 1 to 1, right? Now what I do is, this sin theta cos theta, I just convert it into one trigonometric function. So I can easily apply that concept of sin theta lies between minus 1 to 1, right? So here sin theta cos theta, I just write it p. So p is equal to sin theta cos theta, I multiply divide by 2. So, or 2 sin theta cos theta, here 2p. Okay, so 2p is equal to 2 sin theta cos theta, and 2 sin theta cos theta is nothing but sin 2 theta. Okay, now I know sin 2 theta lies between -1 to 1, right? So 2p will be greater than equal to -1 and less than equal to 1. That means p is greater than -1 by 2 and less than 1 by 2, right? So we want the largest value, that means maximum value, that means 1 by root 2. I'm sorry, 1 by 2. Okay? And if you are asked about the minimum value, then it will be -1 by 2. So that's pretty simple if you are conceptually clear. Okay, so these two formulae, once again I'm telling you, they are really useful, and your basics must be clear if you wish to solve these sort of problems. Okay, if tan theta is equal to m by n and theta lies between 0 to pi, that means upper half of the circle, right, from 0 to 180 degree, then sin theta is equal to, now you must be knowing that in the first quadrant and second quadrant, in both the quadrants, sin theta is positive, right? So definitely value of sin theta will be positive. Now tan theta is what? Perpendicular by base. So perpendicular by base, then this will be definitely m square plus n square, root of m square plus n square, right? So we'll have a positive value of sin theta since it is in first and second quadrant, first or second quadrant I can say. So sin theta is perpendicular by hypotenuse, so it must be m upon root of m square plus n square, but that should always be positive. So we have to put up a modulus sign, right? Because we want the value of sin theta to be absolutely positive, because theta lies in the first two quadrant. Okay, so this is the correct answer. I hope you are clear. The value of this expression, this sort of problem we have already solved in the previous session. Here tan 89 can be written as cot 1. So tan 1, cot 1, tan 2, cot 2, tan 3, cot 3, we are just left with tan 45, that itself is 1. So this entire calculation will be nothing but 1. In the previous question we had to take the logarithm of that. So that's why the answer was 0, because log 1 is 0, but over here the answer will be 1 because we don't have a logarithm over here. Okay, so pretty simple. If a lies in the second quadrant and 3 tan a plus 4 is equal to 0, then value of this expression. Okay, so here tan a must be -4 by 3. So we just have to take the numerical value, -4 by 3. We'll drop minus to put up this the length of the sides. So tan theta is a perpendicular by base, so this must be 4, this must be 3, then this must be 5. Now we have to be careful about the signs. Cot a, if tan a is -4 by 3, cot a will be -3 by 4. So it is 2 into 3 by 4 negative -5. See cos a in and a in the second quadrant. So in second quadrant even cos theta is negative. Cos a over here will be 3 by 5, but since it is negative it will be -3 by 5. So finally it is positive. Okay. And sin a, since it is in first quadrant, it will second quadrant, it will be positive only, so it's 4 by 5, right? So here 5 3s are 15 plus 4 19 by 5 minus 3 by 2. So 38 minus 15, that is 23 by 10. Simple. Okay, fx is equal to cos square x plus sec square x. Then see that so over here we have to find out the maximum and minimum value of this expression, right? Cos square x plus sec square x. See, there are various methods to solve this problem. I just go for a different method, so you will come to know a different concept also. See, am is greater than equal to gm. Am over here is arithmetic mean of numbers is greater than equal to their geometric mean, right? Or I can say geometric mean of the number is always less than equal to their arithmetic mean. In just one case they are equal, am is equal to gm, if numbers are equal, right? Suppose I have two numbers a and b, then their arithmetic mean will be a plus b by 2, their geometric mean will be root ab. So a plus b by 2 is greater than equal to root ab. The am will be equal to gm if both the quantities are same, that means a is equal to b. So if a is equal to b, both sides will be equal, that is am will be equal to gm. Okay, so this funda I'll be using over here. The important thing over here is a and b. The quantity should be positive real numbers. Positive real numbers. Okay, that's very important. If a and b are random numbers, any real numbers, then this property may not stand. Okay, so we have to consider this property true only when both the numbers are positive real numbers or all the numbers are positive real numbers. Okay, so the same funda I'll be using over here. Here it is cos square x plus 1 upon cos square x. Okay, now sec square x can be written as 1 upon cos square x. Now this is a positive quantity, this is a positive quantity, right? So this expression will be what I can say, it is a and this is 1 by a, right? A plus 1 by a is greater than equal to, that is I have supposed two numbers, one is a and other is 1 by a. If a is positive, definitely 1 upon a is also positive. So their arithmetic mean will be this and their geometric mean will be this, right? Because a into 1 by a is 1. Since both the numbers were positive, so a plus 1 upon a is greater than equal to 2. After coming out from the square root, you have to assume it to be positive because you started with positive numbers, right? So a plus 1 upon a is greater than equal to 2 if a is a positive real number. So here cos square x, it is definitely a positive real number. Whatever is the value of cos x, but cos square x will still be positive, right? So this is a and this is 1 by a. So the value will be definitely greater than equal to 2, right? So we have over here fx is greater than equal to 2, right? So a very simple funda I have used over here. Once you are conceptually clear, no need to write this much. This is just for your clarity or for understanding the concept. Okay. Now tan theta is equal to p by q, then the value of this. So you have two options. Either you proceed as it is, divide the entire expression by cos theta, so you will straight get tan theta, right? So it is p sin theta by cos theta, that is tan theta minus q upon p sin theta by cos theta, so it is p tan theta minus q. I'm sorry, plus q. Now tan theta is p by q, so it is p square minus q square, p square plus q square. So that's pretty simple. Sorry, this. Okay, or if you are confused, don't want to go this way, then assume a triangle 3 4 5. Here p is 3, q is 4. So then just put up the value over here, then go for placing the values in the option, but that will be bit lengthy, right? So straight you can go like this, but it may take 30 seconds, not more than that. Now this problem, if sin alpha plus cos alpha is a, then sin 6 alpha plus cos 6 alpha is equal to this. So to make the problem simple, what you can do is you can assume the comfortable values of alpha, right? You have various options to assume the values, right? I just take one or two. Suppose I assume alpha to be 0. Right? So if alpha is 0, sin alpha will be 0 and cos alpha will be 1, then that means a is equal to 1 if alpha is 0. Okay, that means sin 6 alpha plus cos 6 alpha will be nothing but 1. Okay, because alpha is 0, so this expression will be 0 and this will be 1. So among the options, put up the value of a as 1 and try to get the answer as 1. So wherever you get the value of this, any of these options as 1, by putting the value of a as 1, that will be the correct answer, right? Because sin 6 alpha plus cos 6 alpha is 1 if alpha is equal to 0, and sin alpha plus and a is equal to 1 if alpha is 0, right? So I put up a as 1 and see where do I get 1. So if I put a as 1, it will be 0, so I'll be getting 1 over here. In fact, over here also I'll be getting 1. No, right? So these two options I have. So need to go one more step. So what I do, I assume alpha to be 45 degrees. Sine 45 1 upon root 2, cos 45 1 upon root 2. So 2 by root 2, that means root 2. So A is equal to root 2. Now that is 1 by root 2 raised to 6 plus 1 by root 2 raised to 6. So 2 upon 1 by root 2 raised to 6. So precisely that is 2 cube. So that is 1 upon 4. So when A is equal to root 2, you should get the answer as 1 upon 4. So I put A is root 2 over here. So it is 1 minus 3 by 4. 2 minus 1, 1. So it is 1 by 4. So this is the correct answer. Because over here it is plus. So it must be 7 by 4 and we want 1 by 4. So this is finally the correct answer, right? If you put up the value or start cubing and all this, then it will be really difficult for you to do, right? So just assume the comfortable values of alpha and proceed in this manner. Now this question, if tan theta plus sec theta is equal to root 3 and theta 0 to pi, that means it is in between first and in first two quadrants, I mean to say. So then theta is equal to. So instead of making any sort of equations, what you can do is you can directly put up the values from option in this equation, right? For that you must be knowing the basic values, right? 10 suppose I take pi by 3. Pi by 3 is 60 degree, right? Now 10 pi by 3 is root 3, right? And sec pi by 3 is 2. Okay, so we are getting 2 plus root 3, so that is not the correct option. Okay, then 10 pi by 6, that is 1 upon root 3, and sec pi by 6, that is cos pi by 6, cos 30 degrees root 3 by 2, so sec will be 2 by root 3. So it is 2 plus 1, 3 upon root 3, so that is actually a root 3. So this is the correct answer. Okay, we want root 3 and we are getting root 3 by putting theta as pi by 6. So the value of theta is nothing but pi by 6. So simply you can solve it. Now this problem, if sin x plus sin square x is equal to 1, then cos square x plus cos 4x is equal to 1. Now that's also very simple. See, sin x is equal to 1 minus sin square x, right? If you take sin square x this side, so sin x will be 1 minus sin square x, that is nothing but cos square x, right? So here cos square x is what? Sin x, and cos 4x will be sin square x. So this expression is nothing but this expression, and sin x plus sin square x, that's already given as 1. So value of this expression will be nothing but 1. Okay, so do not go for much manipulations, do not make any lengthy equation, no squaring, nothing is required. Similarly, we have this problem on the same concept. Once again, sin x is equal to cos square x from this. Now from this equation you can take cos 4x as common. Then you have cos 4x plus 2 cos square x plus 1, that is cos square x plus 1 whole square, right? And I can even take this cos 4x inside this. So if it goes inside the bracket, it will be cos square x only, right? So cos square x into cos square x will be cos 4x, and this is cos square x. So finally this expression is nothing but this expression. Now cos square x is what? Sin x, and cos 4x will be nothing but sin square x, right? So again we got sin square x plus sin x, that is nothing but 1. Okay, so that's pretty simple. Now this question, if sin a plus cos a is this and sin cube a plus cos cube a is this, then which of the following is true? We have to find out. That means the relationship between m and n. Once again you have an option, just put the value of a, take the value of a, any comfortable value can be taken. Maybe if you take a as 0, then m will be equal to 1 and n will also be equal to 1, right? So because cos cube a is 0, so cos cube 0 will be 1 only, this will be 0. So let us see. 1 plus 3 plus 2, that's not 0, wrong. 1 minus 3 plus 2, that is possible. 1 minus 3 plus 2, that is possible. 1 minus 3 plus 1, that is also not possible. Now still you have to eliminate one more option. So what I do is I assume the value of A to be pi by 4, that is 45 degrees. So sine 45 is 1 by root 2, cos 45 is 1 by root 2. So sine 45 1 upon 2, then m will be 1 upon root 2 plus 1 upon root 2, that is 2 upon root 2, that means root 2, right? Then sine cube A, that is 1 upon 2 root 2 plus 1 upon 2 root 2, that is 2 upon 2 root 2, so I can say 1 upon root 2. So n is 1 upon root 2, right? So put up the value, m cube 2 root 2, 3m 3 root 2, 2 by root 2, that is root 2. So 2 root 2 plus root 2, 3 root 2 minus 3 root 2, 0. So that is the correct option. Okay. I hope you are clear.